In this section, what we want to do is have a look at equations that are going to be coming down to quadratics. We know we can solve linear functions, we know we can solve quadratic functions, but once it gets past the quadratic function, it starts to become harder. So what we want to do is try to get equations that are not quadratics or look like quadratics that come down to being a quadratic equation that we can use and solve either by doing the substitution or you could also use the quadratic formula once you've got it down to a quadratic. So you can see we've done actually a few of these. We did some of these ones in trigonometry, so we were able to solve these ones. And a lot of times you can solve it without going to a quadratic, but sometimes it's easier just to go to a quadratic. And the way we do that is to do some substitution. So if this one we've got here, x minus 3 all squared minus x minus 3 in the brackets minus 2, if we do a substitution of letting u is equal to x minus 3, we can start to write that in this form. So instead of x minus 3, we see u squared. The x minus 3 here just becomes u, and the 2 stays by itself. Once we see an equation like that, well, that's just like a regular quadratic equation that we've solved before. And we can do the factorization. That comes down to our brackets of u minus 2 and u plus 1. So when we solve that, u minus 2 would equal to 0, or u plus 1 would equal 0, because either of those can be equal to 0. So u will end up being equal to 2. Now if u is equal to 2 and u is equal to x minus 3, we can just go do the substitution back again. So the x minus 3 gets subbed back in for u, and we can solve that. X minus 3 is equal to 2, so x would have to be equal to 5. Similarly, if we've got u plus 1 is equal to 0, u would equal minus 1, or x minus 3 would equal minus 1, so x ended up being 2. So we can solve a quadratic equation here in a little bit easier form if we do a substitution. You don't have to do a substitution, but a lot of times it's easier to do that substitution. So in this case, we've got y plus 1 all squared. We've got 5 lots of y plus 1 plus 6. So let's do a substitution of letting u be equal to y plus 1. So in this case now we can get the y being equal to, the u is equal to y plus 1. So we do a substitution, so it becomes u squared plus 5u plus 6. So we can factorize this equation now. That comes down to u plus 2, u plus 3, and then solve them by themselves. U plus 2 is equal to 0, which means if u is y plus 1, we can put that back in, get it down to y plus 3 is equal to 0, so y is equal to minus 3. The u plus 3 now is going to be solved down here, but again, u is equal to y plus 1, so y, that comes to y plus 4, and y must be equal to minus 4. So y is equal to minus 3 or minus 4 in this situation. A little bit harder when it's like that, but much easier to solve when we do a quadratic equation like that. In this example, this one doesn't look like a quadratic to start off with, but we've got something that's nasty in terms of this fraction here. Make it easier, let's multiply through by x on each term. Gives us x squared, that gives us minus 6, and multiplying 1 by the x gives us just the x by itself. Bring the x across, now we're down to a quadratic that we can solve very easily. X minus 3, x plus 2 is our factorization. So x minus 3 gives us x is equal to 3. X plus 2 is equal to 0. It gives us x is equal to minus 2. We didn't need to do a substitution, but what an equation that didn't look like a quadratic to start off with, by doing a multiplication, allows us to get a quadratic and then solve it. We can solve quadratics pretty easily. We can't solve these ones as easily.